In this recording, I'm going to talk through how to solve all the problems in this second review for the Chapter 4 test. So for the first problem, I'm going to start with using, since that triangle is isosceles, it has congruent base angles. And then let's find this angle over here. I'm going to call that y. You can call it whatever you want, but I don't want you to use x because x is already that angle measure. So 62 plus 62 plus y equals 180. That's 124, which makes a y equal to 56. So that's a 56-degree angle. So that's a 56-degree angle, and that since this is 90, we're going to have 90 minus 56, 34 degrees for the other angle measure. And then this one is, this triangle over here is isosceles as well, so its base angles are congruent, so that means that the angle, over here has to be x, and so 2x plus 34 equals 180, 2x equals 146, x is 73 degrees. Problem number 2. Okay, this triangle on the bottom here is isosceles, which means that angle measure is going to be an x. And then the top triangle here is isosceles, so the base angles there are congruent. That's 57. Because those are vertical angles, that's also x. So if I just do 57 plus 57 plus x equals 180, that's what 114 plus x equals 180. And that means x is 66 degrees. Now again, the reason I used x there is because all of those are the same thing. So all of those angle measures would be 66. Problem number 3. Okay, we have an isosceles triangle, which makes that one 75 degrees because congruent sides make the opposite angles congruent in the triangle. So this angle up here, I'm going to call that y. We're just subtracting from 180, or 75, 75, and y has to add up to 180. So 150 plus y, subtract from 180, you have 30 degrees. Okay, so that is, this angle measure right here is 30. Subtract from 90, that tells you that this one is 60 degrees. And then again, this triangle over here is isosceles. Its base angles are those two angles. So, oh, don't need that. Let me back up. And since we're looking for x, these are a linear pair, right? Because they add up to 180. So just 180 minus 60 would give us 120. All right, and then problem number 4. Let's see, we have 136. So I'm going to do 180 minus 136 to get 44 degrees. That's this base angle. And that means this base angle here is also 44. And then the vertical angles are congruent, so that base angle is 44. And this one over here is also 44 because, oops, 44 because that's an isosceles triangle here. Okay, and then I'm going to put y there to figure out that angle measure. There are 2 different ways you can do this, but one way is to say those add up to 180 in the triangle. So that's 88 plus y equals 180. And y would be 92. So then that means that the measure of angle 2, if this is 92 degrees, that means that this angle measure is 88. Now, if you noticed that that's an exterior angle, you could use the exterior angle theorem and say 44 plus 44 gives us 88. We don't have to actually calculate that. Okay, but here doing 180 minus 92 would give you the 88. Now we were told that measure of angle 2 is x plus 94. So x plus 94 is equal to 88, and that makes x negative 6. Notice I didn't do anything with this x plus 94 until I got down to what the actual angle measure is for angle 2. I didn't bother putting x plus 94 down here because it tends to confuse you. If you put x plus 94 there, then you start doing weird things because you get confused. Just use the numbers until you get down to the last part. Okay, problem number 5. Write a statement or mark the diagram that indicates the triangles in each pair are congruent. So we have all the angles marked congruent, all the sides marked congruent. So a congruent statement would be triangle. I'm going to go single, double, triple. So y, x, z, single, double, triple is congruent to triangle. The single marked angle is x, the double marked is y, and then the triple marked is d. Notice that on this problem, y goes to x and x goes to y. Okay, we're not matching y to y and x to x because it wouldn't be a line of symmetry here. You don't flip it over to make things match up, right? Because that would make one and then the double marked angles match, which they don't. So you'd have to cut it apart and twist it. Okay, so that's a congruent statement. And then for the second one, it's saying mark everything that matches. So angle S should be congruent to angle F. Angle Q should be congruent to angle G. And then angle R is congruent to angle E. Okay, across from the single marked angle is segment QR, and then across from F is GE. So QR, GE. Okay, across from a double marked angle, I'm going to put 2 marks on those sides. That's RS and FE. And then our third sides there should also match. Okay, it doesn't matter actually how you mark them. If you did 1 mark here and 2 marks there and 3 marks there, that's perfectly fine. As long as you have S matching with F, and you have Q matching with G, and you have R matching with E. Okay, complete each congruent statement by naming the corresponding angle or side. Okay, so triangle UVW is congruent to KWJ. So UV is right here, should match with KW. Okay, now let's kind of mark that and make sure that makes sense. U and K, V and W. So from single to double is UV, from single to W is KW. Okay, and then for this one, angle NLM should be congruent to angle RLM. So L matches with L, M matches with M, and R matches with N. So N, LM, and RLM. That makes sense. Okay, determine if the 2 triangles are congruent. If they are, state how you know. So we're going to mark everything that we know on the picture. Vertical angles are congruent. Triangles are congruent by HL. Remember that HL means hypotenuse leg. Hypotenuses only exist in right triangles. So if you don't have the hypotenuses marked, and they're not right triangles, then it can't be HL. Okay, we've got a pair of angles, pair of sides in between that and the next pair of angles. Angle, side, angle. Reflexive property of congruence. Then the triangles are congruent by side, side, side. All right, this one we've got vertical angles are congruent. That's all we have. One pair of sides, one pair of angles. Not enough. None. Okay. Vertical angles are congruent. So that means it'll be angle, angle, side. Okay, again, remember that it's the order. You have two angles and this side is not included. Okay, it's not angle, side, angle because angle, side, angle would go angle, side, angle. But that's not the side that we know. Okay, it's two angles followed by a side, not two angles with a side between them. Angle, angle, side. Number 14, reflexive property of congruence, side, angle, side. State what additional information is required to know that the triangles are congruent by the reason given. So for side, angle, side, it says state, and that means don't just mark it on the picture, actually state what you would have to know. So the only way that you can get them congruent by side, angle, side would be if you knew this segment here and that segment there matched up, because our reflexive is going to be congruent. We don't have to state the reflexive because we already know that those are congruent. So what would we need? We need segment IJ to be congruent to segment TK. Now it would be okay to say JI and KT, but you have to make sure the order matches. Okay, I did the unmarked to the double marked, unmarked to double marked. All right, for hypotenuse leg, well, again, we've got a reflexive segment, so we don't need to be given that. But there's two different possibilities here, right? If we knew that segment FT was congruent to segment GH, that would be a hypotenuse leg. But it's also possible to have, nope, I take back what I just said. Okay, number 16. So for hypotenuse leg, we know that that segment right there needs to be marked congruent. And then in order to be hypotenuse leg, we would want to know that these other segments here, the hypotenuses are congruent. So we would need to know segment FT is congruent to segment GH. Then for angle, angle, side. So we don't have to be given the vertical angles. We know that those are congruent. What we do need to be given for angle, angle, side, I want to know that angle measure there and this angle measure here. Okay, I don't want to put this angle because that would be angle, side, angle, right? And I don't want this angle because that's angle, side, angle. So I want to know that angle F is congruent to angle P. And then for number 18, again, we have our reflexive segment. We don't need to have that given. But what we do need to know is that the other pair of angles would be congruent that makes the side between the angles. So I want to be able to say angle, side, angle. That means that I want the angle up here to be congruent. And then for angle, side, angle, I want the angle over here to be congruent. Okay, so we need that angle, we need that angle. Let's make sure we name them correctly. Angle XVW is congruent to angle, okay, X goes with J because they're the ones that are not marked. I went from X to V to W. So I'm going to follow the same order here. J to the one that's marked as W, and then to V. Okay, proof. Given that segment JK is congruent to segment ML, and angle JKL, that's the big angle here, is congruent to the big angle here. Prove that segment JL, which is this segment, is congruent to MK, which is this segment. So it looks like we want to take the triangles and kind of pull them apart here. So I'm going to redraw this triangle. I'm going to move it up here actually. This is JKL. And then this triangle is MLK. Okay, so we're given JK is congruent to ML. Got it, given. The other given is that angle JKL is congruent to angle MLK. JKL, MLK. Okay, segment KL is congruent to segment KL. Now, when you see it on here, hopefully that screams to you that that's reflexive. You can also see it's reflexive because it's where the two triangles overlapped before I pulled them apart. Right? If I put them back together like that, they both share that segment along the bottom. The segment KL is in both of the triangles. And then the triangles are congruent by side, angle, side. Now it's asking you to explain why segment JL is congruent to segment MK. JL is here, MK is here. Why are those congruent? Because the triangles are congruent. We're proving that segment JL is congruent to segment MK. The reason is definition of congruent triangles. Remember, you can also say corresponding parts of congruent triangles are congruent. Next proof. Segment RT is congruent to segment RV, and then the measure of angle TRS is congruent to is equal to the measure of VRS. So that's going to be our given information. Oh, they split into two givens. So there's the first given. And here's the second given. Okay, those are both given, marked on the picture. Angle TRS is congruent to angle VRS. So remember, when it looks very similar but it's equal to congruent, that is definition of congruence or congruent angles. Segment RS is congruent to segment RS. Reflexive property of congruence. And then you can see the triangles are congruent. That would be side angle side. Let's get the order right. RTS would match with RVS. Side angle side congruence. Okay, and then the parts are congruent. RST is congruent to RSV because the triangles are congruent, so definition of congruent triangles. Or corresponding parts are congruent, triangles are congruent. Okay, proof number 6. Segment AD is an angle bisector of angle BAC. So this is bisecting this angle. Okay, that's a given. And then our second given is that AB and AC are congruent. Okay, so to be an angle bisector means it cuts the angle in half. So it'll make angle 1 and angle 2 congruent. AB is congruent to AC, given. Okay, and then reflexive is going to be segment AD is congruent to segment AD. So you make sure you mark that stuff on the picture. Okay, then you can see the triangles are congruent by side angle side. And then lastly, the pieces are congruent because the triangles are congruent. So again, definition of congruent triangles or corresponding parts of congruent triangles are congruent. On the next proof, we're given that N is the midpoint of segment AB. That's given. Well, definition of midpoint. What is a midpoint? What does that mean? Okay, a midpoint divides a segment into two congruent parts. That's going to tell us that those two pieces are congruent. So segment AN is congruent to segment BN. And probably NB. Definition of a midpoint. Okay. Then we have a given here, a segment AX is congruent to segment NY, so that's given. Let's make sure we mark that on the picture. Segment AX is congruent to segment NY. And then segment NX is congruent to segment BY is the other given. Mark that on the picture. Then you should be able to see on the picture, the triangles are congruent by side, side, side congruence. Okay, and then again, once you prove the triangles are congruent, then you can say the pieces are congruent by definition of congruent triangles. So angle X is congruent to angle Y because they're in the same position in the two triangles. Like the triangles are congruent, so all the parts are congruent. The next proof says it's given that RT is congruent to RV and TS is congruent to VS. It looks to me like we're going to be splitting up these givens because step 3 says reflexive property of congruence, which means we're going to have that middle segment marked congruent. Segment RS is congruent to segment RS. Is that step? And so our other given of segment TS is congruent to segment VS will be our other given. Okay. Triangles are congruent by side, side, side. Let's make sure we get the order correct. So something like RTS, RTS is congruent to RVS. And you can have any order for the first one, but the second one has to match the order of the first one. And then again, once you prove the triangles are congruent, you can say the pieces are congruent by definition of congruent triangles, or corresponding parts of congruent triangles are congruent. All right, the last problem, segment segment VB. The last problem says segment VB bisects angle EBO. Okay, that's a given. Definition of angle bisector means that this angle is cut into two congruent parts. That's going to tell us angle 3 and 4 are congruent. Okay. The other given is that VB also bisects angle EBO. So angle EBO is over here. If it bisects that angle, that means that angle 1 and angle 2 are congruent by the same reason here, definition of angle bisector. I forgot to write given up here for step number 1. Okay. How do we know that BB is congruent to BB? Well, that's a shared side, that's reflexive. And then the triangles are congruent by angle side angle. So triangle BEV is congruent to triangle BOV. Angle side angle. Okay, and then again, the last step is going to be because the triangles are congruent, that makes the pieces congruent, which is definition of congruent triangles, or corresponding parts of congruent triangles are congruent.